Let's start. Today what I want to do is as follows. I would like to talk about contracts and maybe give sort of the result of those contracts. I think last time, did we talk about buyback contracts? Okay. Now we're going to talk about buyback contracts under which we have salvage as well. Did we talk about that? No, I think our model was without salvage. So what I will do is I will pause the contract, give the result, and explain how the model can be written. But now you can see that what you are doing, actually, each contract style is basically a news vendor problem with different parameters to consider. So let me start with the buyback contract. Okay, now this time we're going to have the salvage. So what are the parameters? Well, the parameters are C is the unit cost of the manufacturer. Okay, and we're going to have S as the salvage value when the item is going to be salvaged. And then we're gonna have, these are sort of given values, and then we have the price P. Remember? Okay. Now there are two parameters that we want to set. W is the price that is called the transfer price, the price that the buyer is going to give to vendor per unit, and B is the buyback price. In other words, for those items which are going to be which are not sold by the buyer, can be returned to the vendor by this money, and the vendor can salvage it, of course. Okay, that's the idea. So if you set this system as a news vendor problem, and that's the key part. Now, any doubts on that, how we can do that? Well, remember, what is the routine is as follows. You solve the centralized problem, okay? And then you solve the decentralized problem for the buyer. And the quantity that the buyer is going to buy is going to be equated to the quantity which is going to be bought in a centralized system. So the parameters which are going to satisfy that equation, or those equations, that will be two equations, are going to be the equations that will give us the contract, the buyback contract parameters, and each of those parameters is going to yield a certain profit decomposition between the buyer and the vendor. Okay? So, as we did last time, so lambda is, if you recall, so these are the two equations that we are going to have. So let me write this here. So buyback contracts with salvage this time, with a pair WB, coordinate the channels if we have two equations to solve. Lambda C minus S is equal to W minus S minus B, and lambda P minus S is equal to P minus S minus B. Okay, and in this case, lambda percent of the channel profits go to the buyer, and the rest to the vendor. Okay, now this is one of the typical contracts which is used in book distribution. Okay, remember the bookstores or some printing houses has an agreement with the bookstore. And what they would do is they would simply ship a certain amount. And after some time, if the books are not sold, usually the print house is ready to buy to buy it back, but basically they don't give the original cost, but they give a smaller amount. So this is one of the typical deals that they have. And of course you have some kind of a salvage value which is available. Okay. Now here, this is interesting because in this setting, okay, let me consider the salvage value. In this setting, the nice thing is as follows. For example, let me give an example from the book distribution. Now, usually what happens is that when a new edition of a certain book comes out, the old edition is out of date. So what the retailer, the buyer of the books, a bookstore, for example, is going to do is as follows. Will simply notify the print house that I have 25 left. And so the print house is going to give a discount to the new ones which are sold according to that 25. In other words, instead of buying it physically back, what they would do is they would simply, on the records, show that 25 is left there. So they claim that they are as if they are doing it as if they are replacing it, but they don't replace it physically. So the bookstore still keeps the old edition as well, but value-wise, it doesn't have much value left. So the salvage value might correspond to the case where the bookstore sells the books in a sales and gets maybe a very small cash, and that's the salvage value. Okay? Worst comes worst, they are going to send it to a paper factory and will become paper. So that will be even the cheaper price. So physically, sometimes the bookstore, well, the print house is not going to be interested in getting those back because it's not very meaningful. You see, here, of course, you have the problem of trusting each other. And this happens in practice as well. But, I mean, it's not very widely tested, of course. We're talking about very single-out cases. Book business is usually still based on trust. Okay. Now, this is the buyback contract. Now, another one is the revenue sharing contracts. So basically, the idea here is that the vendor or the manufacturer charges W per unit purchased, and it also okay, so it's basically charges W per unit. Now, additionally, the retailer shares 1 minus phi of its revenues with the vendor. So the W, did we talk about this, the video rental business? Yeah. Okay. So W is the upfront money per unit that is charged. Then at the top of that, 1 minus phi of the total revenue which is obtained by the retailer or by the buyer is going to go back to the manufacturer. Now, what is the meaning of this, of its revenues? Now, revenues are going to include the sales plus the salvage. Okay? In other words, if you salvage, still like that percentage is going to go to the vendor. Of course, you may not have that, and that will bring you other solution to the same problem, of course, depending on what you are sharing. But in general, we expect that everything is shared. So in this case, you can still set up the news vendor problem for both of cases. and then make correspondence. The conditions that are obtained will be as follows. Lambda times P minus S is simply phi times P minus S, and lambda times C minus S is equal to W minus phi times S. So we require the solution of this system, and again, lambda percent of the channel profits go to the buyer, and 1 minus lambda percent of the total channel profit goes to the manufacturer. Okay, so it's the same thing again. Now you can see from here that actually this lambda is going to be equal to phi, which means that that percentage is already defined. Now how can one apply something like this in practice, and something like this as well? First thing that you would do is you would sit down, buyer and vendor, and agree upon the way that you are going to divide the profit. Now that's part of the power game, but there is some kind of a bargaining going on there, but this is the way that it goes. So once you decide the value of lambda, that will immediately correspond to some W and B in this case, and some phi and W in this case. Okay? So there are a large number of possibilities which is going to yield the most efficient solution for the system, but each of them is going to give different profit divisions. Okay, any questions on this? Okay, now let's talk about another one. This is called the quantity flexibility contracts. This is like the buyback, but it has some different features. So here again, the manufacturer or the vendor charges W per unit purchased, and the retailer can return unsold units up to a portion delta of the initial order quantity. So what happens is that you order Q units, and delta is, let's say, 20%. So it means that you can return 20% of the initial Q units that you ordered without any loss. So it means that you're going to get what you paid back. Okay? And this is allowed. Of course, quantity flexibility is very similar to buyback, but what is the difference? In buyback contract, you have no limitation on the amount that you can return, but the money that you're paid is less than what you paid initially. Whereas in quantity flexibility contract, there is a limit on the total amount that you can return, but the money that you receive for each return is the original money that you paid. So you can see that actually they are very similar in a lot of aspects. But of course, the way that the risk is shared by the vendor and the buyer is going to be a little bit different. Now, it turns out that this contract also coordinates the system, the single problem. But this time, the pair which is, so the way that the relation in between this pair is going to be as follows. So we're going to have S plus P minus S times 1 minus F of Q optimal. So let me use square parentheses and divided by 1 minus f of q optimal plus 1 minus delta times f 1 minus delta times q optimal. So I close this parenthesis, that one, and the square one. Okay? So this is the condition that should be satisfied between W and the delta value. Now, what is the Q optimal? Q optimal can be found from the centralized solution, which is not going to contain any one of those variables. Okay. But you can see here that, again, we are going to have a nonlinear structure, but the profit division is not going to be as clean as the other one. You have to compute the way that the profit is divided. Okay. Now, again, how can we obtain this? I'm going to repeat it again. You solve the centralized problem. You obtain the Q optimal for the centralized problem. Then you solve the problem, the decentralized problem for the buyer. What you want is you want to select the parameters of the quantity flexibility contract, which is in this case W and delta. Okay? You want to find that W and delta, which is going to yield the same Q value. Of course, you are going to, as you see from here, here we have two unknowns and a single equation, which means that there are infinite different ways of doing it. And each of them is going to yield a different profit division. Okay, like the ones that we have here, actually. Here we have actually three unknowns. Okay, but once you set the way that you are going to divide the profit, explicitly, then you can find the policy parameters. Whereas here, you cannot do that explicitly. Because of, I mean, these are sort of like uglier looking terms. Okay, any questions on this? Now, you can see that you can try any contract that you want, okay, on the newsboy problem. And if you can find something like this, a solution like this or like the other one, it means that it is coordinating the system. Otherwise, it doesn't coordinate the system. Now, most of the contracts that we see here are coordinating the simple news vendor type system. Okay. Now, are they coordinating more difficult or more complicated systems? We don't know that part. Okay, because you have to analyze each of them separately. Okay, any questions on this? Okay, now another typical contract. This is also, I think, well, another typical contract will be the sales rebate contract. This is a contract which is used in practice a lot. The modeling of this is also possible, but I'm not going to talk about that. This is a little bit different than the others. And when you look at this, you're going to see that it is very meaningful. Okay, so the manufacturer charges W per unit purchased. But then gives the manufacturer, I mean the supplier or vendor, I'm using those words, but then gives the retailer, the buyer, a rebate of R per unit sold as long as the quantity sold is above a threshold T. So what is the deal? The deal is the vendor looks at the total sales. If the total sales is larger than a certain T, okay, the manufacturer, the vendor is going to give an additional discount to the items which are bought. So if you can sell more, okay, you're going to get that rebate. Rebate means the money which is paid from the supplier, from the vendor to the buyer. Now, this is actually a typical contract that they use. And what they would do is they would have multiple items, not a single item, but usually the vendor, the supplier, sells multiple items to the buyer. And if the total volume of sales exceeds a certain limit, they are going to give some kind of a rebate. Now, what is the use of this? By doing this, the supplier makes sure that the buyer has enough incentives to sell more, so that they are going to channelize their efforts to do that, and in that case they are going to make a larger profit. And it is also very helpful for the manufacturer, because basically at that point when the manufacturer is then going to be able to sell more. Okay. So, but then we'll charge a little bit less, but wouldn't care. Probably it is going to increase the profit. Now, it turns out that what are the parameters of this? The parameters are actually W, R, and T. So you have three parameters, actually. It turns out that this is also a contract that is going to coordinate the channel. Now, people would go even further. Now, this threshold might be related to the sales or might be related to something else. Let us say that we have the following situation. You have a business which is very much dependent on the weather conditions. Okay? In other words, you cannot do much because of the weather conditions. So the risk comes with the weather conditions. For example, if you are selling ski apparel, and if the weather turns out to be very mild this winter, then you won't be able to sell a lot. So as a retailer, the risk that you have is the demand risk is dependent on the weather conditions. So now, in these type of cases, you can have this sales rebate contract, and the rebate is going to be a function of not the quantities that are sold, but on the, let's say, average temperature or the variance of temperature. This is possible, actually. So this is usually done for the machines that are used in hard winter conditions, like Caterpillar. Caterpillar is selling those huge work machines which are going to plow the snow and so on and so forth. Now, you are basically selling those to some customers. If the weather goes fine, nobody buys them. But you still want them to be sold by the retailer. You have to have it there. So in that case, the rebate which is given is going to be active if the weather is not that cold. So I mean, you can do it. Now, what is the main idea in these contracts? You are simply sharing the risk in the supply chain. Now, traditionally, only risk is kept with the entity that sells it to the final customer. That entity carries all the risk traditionally. Now, with these type of issues, what you are doing is you are basically distributing the profit as well as the risk. So this is the main idea of the contracts. That's the reason why you can go into larger businesses, because you can share the risk with another entity. If you go too much ahead in this, of course, then you have financial crisis. Okay, this is actually a result of these type of games. But up to a certain extent, it makes a lot of sense. because both of them are affected by the same large risk. So as a result, what happens is that as a result of sharing the risk, now the entity which is closest to the customer is going to buy more, okay, because somebody else is sharing the risk. So this is more or less the idea. Any questions on this? So this is, I think we're going to see some examples when you are going to make presentations. We're going to see, for example, quantity discount contracts in your paper, I think, in the paper that you are going to present. But there are many other possibilities. Of course, there are applications of these to multiple periods and different types of games and so on and so forth. But I think at this time, I think this is going to be sufficient. So what you are expected to do is you are expected to be able to model a given contract situation. I mean, this is the bottom line. Now, you have all the tools that is available to model a certain contract structure which is given. Okay? And then you can show whether it coordinates in that given environment or not, if it is possible, of course. Okay, questions on this? Now, for 5 minutes, I would like to talk about the product and process redesign problem. Now, there are two papers that I didn't mention. Okay, so it means that in total we skipped 1 week. Okay, so I will simply talk about those. You are not going to be responsible, but I want to explain the basic idea of the effect of our knowledge in supply chain on product and process design. Okay, so I think this is important. We're going to have one paper discussing similar issues, but I think to talk about those is probably reasonable in 5-10 minutes. Now, one of the things which is rather different in modern times is that we have a lot of products, similar products, substitutes, which are manufactured at the same time. So, for example, at the time we had only one automobile with a single color and the Ford T car, single color and no accessories. All the accessories were similar. Whereas now you can create your own automobile, actually, by selecting different options within a certain version class. So the number of products that you can have in terms of SKU is thousands, 10,000s, whereas the total sales is also in 10,000s. Now, of course, there will be certain brands, certain types, which are going to be liked more, and which are more meaningful combinations, and those are going to sell more. But actually, if you leave the customer alone, probably there will be more sales and more options which are sold. Okay? Usually, the salespeople are affecting the buyers so that they will buy the ones that they have available. Okay, so this usually happens. They would say that, okay, then, but you're going to wait for 3 months, and I don't know whether the price is going to change or not. So once you say that, then immediately people would go and buy what is available at that point in time, which is an important factor, of course. So in that case, the idea is that we can talk about the reality of product proliferation, which means that we have a lot of products which can be derived. But what is the main problem with this is that, and if we have as we give more choices, this is going to result in a number of disadvantages in the operations that we have. Now, the first disadvantage is inaccurate forecasts. Now, it will be extremely difficult to forecast in that detail. I mean, we have good forecasting procedures, but think about the details that you need to take into account to forecast. Okay, you won't even have a nice time series because the numbers are so small. Okay, so the forecasts on that basis is going to be inaccurate. Now, as you have very inaccurate forecasts, what is the result of that? If you want to give a certain service level, you're going to have very high inventory investments. Now, on the other hand, we know that working capital is getting more valuable every day. You don't have, in the financial, in an era where financial problems are there, working capital is going to be very expensive. So high inventory investment is physically not possible. And unfortunately, even if you have very high inventory investment, your customer service still will be not very good. In other words, at one location you would be selling, you would be satisfying the customers, in another you won't, and so on and so forth. So this is basically the problem. Now, given this environment, so how can the knowledge of this environment affect the way that we design our products? So the idea is that in this supply chain course, one of the things that we learned is the idea of centralization. Now, what is the use of centralization? If we can centralize most of the things, then we will be able to bring up certain things together. As a result, forecasting would be easier if we can centralize. And as a result of that, the inventory which is kept is going to be smaller. Now, the idea can be taken to a certain product level. Let's say that this continuum, okay, let's say that this is the manufacturing, this is time, and let us say that this axis represents a manufacturing process. So what will happen is that, and let me rescale this line so that we have 0, 1. So 1 is the point where we are going to have the end products, and 0 is the point where we start the manufacturing. Okay? Of course, this is something that will be repeating itself, but I am taking only one of these occasions. Now, what we can do is, if you can create a design which is going to have common features up to a certain point, the working process that you are going to keep will be less and less. So what happens in general is that you start with a common skeleton in manufacturing. Let's consider automobiles. Okay? You start with a common skeleton, and the longer that you can keep the common skeleton in the manufacturing process, the better it will be with respect of knowing the demand and responding to that demand. So the idea is that there is a certain time t after which you have to differentiate your products. But up to this t, the products are more or less going to be similar. Now, this idea is called product differentiation or delayed product differentiation. Now, the more that we have this t closer to 1, the more savings that we are going to have with respect to working process inventory, with respect to knowing the demand and manufacturing the individual products accordingly. Okay, because t is now closer to the demand time, the lead time is smaller, so that you can manufacture whatever you need in a better way. So, and the working process will be the least possible working process, because it's going to be common, centralized. Common means centralized, and then you're going to save a lot of money in this manufacturing. But problem is, can we really redesign the processes in this way? Well, there are some examples that it can be done. We're going to see some examples, but this is the basic idea of product and process redesign by using the concepts of supply chain management. Okay? So this is the extent that I will talk about this. We're going to see some examples. There are 2 papers that we were supposed to see, but we are not going to, we don't have time to see them. And those 2 papers actually covers issues like this. We're going to have another one being discussed actually, and this is number 4. You're going to discuss it actually next Tuesday. So you may want to use of the papers that we didn't study, so that might be a little bit difficult, but and it's called postponement strategies. Now, again, let me repeat the idea. The later T is conceptually, the more benefits that you are going to get. But of course, to delay T, what you have to do is you have to make investment. Okay, so there is always a trade-off with respect to the investment that you want to make and delaying that T. Okay. Any questions on this? Okay. This is the end, and we have 3-4 minutes left, so I want you to fill this evaluations. Maybe you are coming back to the department, so you can do that. And other than that, I'll see you on Tuesday with the first presentation.